Hi, myself Alvin Jose, under the guidance of Mr. Sanju Sebastian, Assistant Professor, Department of Electronics and Communication. My topic is wireless charging techniques. Moving to the content slide. These are the contents: introduction, basic block diagram, history of wireless charging techniques, overview of an inductive wireless power transmission system, advantages and then disadvantages, future trends, applications, companies involved, and then conclusion. Moving to the introduction slide. Wireless charging is a technology that allows devices to charge their batteries without the use of physical connection. That is, we don't have to use any cables or cords for the charging of devices. Instead of plugging a device into a power source, wireless charging uses electromagnetic fields to transfer energy from a charging pad or base station to the device's battery. That is, we don't have to plug in the device, we only have to put the device in the charging pad or the base station. Then it will automatically charge the device's battery if the device is compatible. Next is the working of the wireless charging. Wireless chargers use a coil of wire to create a magnetic field. When a device with a compatible receiver coil is placed within the magnetic field, an electric current is induced in the receiver coil. This current can then be used to charge the device's battery. The efficiency of wireless charging depends on a number of factors. They are distance between the charger and the device, alignment of the coils, type of materials used in the charger and the device. These are the efficiency factors affecting the charging speed of the wireless charger. This distance, it is considered wireless charging. Minimum it is 4 centimeter, and the alignment of coils should be correct for proper wireless charging. And type of materials used also affect the charge received and sent. Next, this slide shows the basic block diagram of wireless charging. The power source, the power transmitter sends the current from the power source to power, and the power receiver receives and sends the current to the battery. Next is the history of wireless charging. We told the work for wireless charging begins from the electromagnetic induction, that is the basic principle behind the wireless charging. 1831, Faraday's law of electromagnetic induction was formed, and in 1890s, Nikola Tesla's experiments, that is, tested the Tesla coil, and similar experiments in early 20th century, development of resonant inductive coupling, and then moving to 1970, experimenting wireless charging on electronic devices, and 2007, Wireless Power Consortium was founded. 2008, introduced UA standard for charging. First UA certified devices was uh, formed in 2010, and in 2011, resonant wireless charging gained popularity. 2015, wireless charging was introduced in electronic vehicles, and in introduction to fast wireless charging was done in 2017. Innovations was continued in this field. 2023 was it's also witnessing innovations in this field. More gadgets are coming in compatible with wireless charging technology. Going to the next slide, wireless charging techniques. Basically, wireless charging can be divided into two categories. That is on the by by the classification of range. It can be divided into on the basis of range of power transmitted. It can be divided in near field charging and far field charging. In near field charging, inductive charging and resonant charging is a classification for near field charging, and in far field charging, microwave charging and radio frequency. Those are the far field charging methods, and then optical charging and thermoelectric charging. So near field charging, in this type of charging, It uses electromagnetic induction or resonance transfer to transfer power over a short distance. It is the most common type of wireless charging and is used in most commercial products. So near-field charging techniques, inductive charging and resonance charging. So moving to inductive charging. Inductive charging uses two coils, a primary coil in the charger and the secondary coil in the device to be charged. When these two coils are placed close together, an alternating current flowing through the primary coil generates a magnetic field. This magnetic field induces an AC current in the secondary coil, which charges the device's battery. This is the figure showing the working of a inductive charging circuit diagram. There are two coils shown as said earlier. The transmitting circuit and the receiver circuit is shown here. Power is transmitted as electromagnetic waves. Next is the resonance charging. It is an improved version of inductive charging. In this technology, both the transmitter and receiver coils are resonated at the same frequency. For more efficiency, an intermediate coil is placed between the two coils. The significant advantage of this technology is that it can transfer power to multiple loads simultaneously, operating at multiple frequencies. Here is a figure showing a resonance charging circuit diagram. The transmitter and receiver side resonates at the same frequency. For efficiency, a resonating coil is placed between the transmitter and the receiver. The main advantage of this resonance charging is that it can, as said earlier, it can handle multiple devices simultaneously and can handle various frequency devices. Next is the far field charging. In this type of charging, wireless charging uses microwaves or radio waves to transfer power over a long distance. It is less efficient and can be harmful to human health, but it has the potential to charge devices without the need of direct contact. RF charging is divided into microwave charging and radio frequency charging. First is the microwave charging. Microwave charging, as in the name, it uses microwaves to transmit power to a device. Microwaves are absorbed by a receiver in the device and converted into electricity. Microwave charging can be used to charge devices over long distances than inductive or resonant charging, but it is less efficient and can be harmful to human health since it uses microwaves to transmit the electric current. Microwave is harmful to human health compared to other transmission methods. This is the figure showing microwave transmission charging. The transmitter transmits the microwave and the microwave passes through the air, which is the medium for microwave, and the receiver side receives and charges the battery of the device. Next is radio frequency charging, that is RF charging. RF charging uses radio waves to transmit power to a device. The radio waves are absorbed by a receiver in the device and converted into electricity. It is similar to the microwave charging, but it uses low frequencies and it is less harmful to human health. This is a figure showing RF charging method. Similar to the microwave charging, the transmitting antenna transmits the radio wave and the receiving antenna with the proper inner circuits. The receiving antenna receives and charges the device's battery. Next is optical wireless charging. In optical wireless charging, uses light to transmit power to a device. The light is absorbed by a photovoltaic cell in the device and converted into electricity. Optical charging is still in its early stages of development, but it has the potential to be very efficient and safe. And thermoelectric wireless charging. Thermoelectric charging uses the temperature difference between two materials to generate electricity. This type of charging could be used to charge devices from the body heat of the user from the heat generated by electronic devices. Thermoelectric charging is also still in its early stages development, but it has the potential to be very efficient. Next is an overview of an inductive wireless WPT, that is wireless power transmission system. In inductive wireless power transmission systems, the transmitters and the receivers are placed in close proximity to each other. That is, the TX and RX are held at close proximity to each other. A power supply in combination with the transmitter circuit provides an amplified sine wave that can be controlled in both the frequency and amplitude. The transmitter antenna is coupled with the receiver antenna by means of electric or magnetic fields. The receiver circuit consists of an AC-DC conversion by means of a rectifier, smoothening capacitors, and optionally a switched mode power supply, that is SMPS. The main components of this system are, that is inductive WPT system, are power supply and then transmitter circuit followed by transmitter antenna and receiver circuit followed by receiver antenna. Here's a figure showing the structure of an inductive wireless power transmission system. This is the power supply. Transmitter circuit transmits the power through the transmitting antenna from the power supply. There's a magnetic field or electric field in between these two transmitting and received antenna. The receiver antenna receives the power from the transmitter antenna and converts it to rechargeable power and use it to charge the device. These are the components for the inductive WPT. First is the power supply. WPT systems cannot directly use the AC mains to power the transmitter circuit. Therefore, an initial conversion to DC is required. Mains-powered systems typically contain a flyback converter to achieve a safe, stable DC voltage. Alternatively, the transmitter can be powered by a battery, that is the power supply. Next is the transmitter circuit. It consists of the pre-regulator and the inverter. The pre-regulator, in some implementations, the pre-regulator is introduced between the power supply and the inverter with the purpose of controlling the amplitude of the sine wave that will be fed to the antenna. The pre-regulator is not always required since many systems can operate on fixed voltage. The pre-regulator can be found in the form of SMPS, such as step-down, step-up converters. They have very low uses and hence are highly efficient. Inverter. Different types of power inverters can be considered in the design. Power amplifiers such as Class A, Class B are not efficient enough for WPT applications. Alternatively, Class C, Class D, and Class C amplifiers can provide a more efficient solution. Mostly that half bridge or full bridge DC-AC inverter is selected for coupled WPT systems. Next, this figure shows the transmitter with the pre-regulator and the half bridge inverter. So this circuit creates an amplified periodic signal. The power FETs are controlled with an appropriate gate driver integrated circuit. The gate driver input is connected to a square wave generator. The pre-regulator can be seen as a DC inverter converter with the adjustable output voltage connected to the power inverter. Changing the pre-regulator output voltage results in a higher amplitude of the square wave. Both the pre-regulator and the oscillator can be controlled with a microcontroller unit to change the amount of power transfer, save energy, and to optimize the link efficiency. Next is the receiver circuit. The AC voltage coming from the antenna and compensation network is converted to DC with a rectifier and a smoothing capacitor. Then using this DC, the receiver side charges the battery of the device that is to be charged. Next is the advantages. First advantage is convenience of wireless charging. Wireless charging is more convenient than wired charging because you don't have to carry or worry about the finding a cable or plugging it in and out. You can simply place your device on a wireless charger and it will start charging automatically. Durability. Wireless chargers are more durable than wired chargers because they don't have any cables that can break. Safety. Wireless charging is more safer than wired charging because there is no risk of electric shock. Next is the disadvantages. First one is speed. Wireless charging is typically slower than the wired charging. Then placement. You need to place your device on the wireless charger correctly. That is, we have earlier said in the efficiency matters placement. Uh, we have to correctly align the wireless device to be charged in the wireless charger. Next is the compatibility. Not all devices are compatible with wireless charging. Cost. Then cost. Wireless chargers are typically more expensive than wired chargers. These are the few. Next is the future trends. That is faster charging speeds. We can expect faster wireless charging speeds in the future. Currently, wireless charging works at a range of 5 to 20 watt. But in case of wired charging, it is maximum speed capable of wired charging is up to 210 volt. I think it is 210 volt. And then more efficient charging and greater charging distances. And the maximum distance that can be charged using wireless uh, charging technique is up to 4 centimeter in mobile phones. We can extend the distance by doing researches in this field. Next is more versatile charging. Moving to next slide, application side. These are some images of the applications of wireless charging. Transportation, charging of electric vehicles are done through wireless charging. We can show the charging of an electric bus and an electric car. Then portable electronics, we can charge smartphones, laptops, and then smartwatches. Many device gadgets nowadays are compatible with the wireless charging technique. Next is the medical implants. We can charge medical implants using this technique and warehouse equipments and then military gears. That is military equipments. Next is the companies involved. Powercast, Electricity Corporation, Ossia Energies, Lumen Private Limited, Toshiba Electron Wireless Limited. These are some of the companies involved in the research of wireless charging and its products. So moving to the conclusion side, wireless charging is a convenient, safe, and efficient way to charge your devices while it is still in its early stages of development. The future of wireless charging is very promising. We can expect to see faster charging speeds, more efficient charging, greater charging distances, and more versatile charging in the years to come. In conclusion, I believe that wireless charging is the future of power delivery. It is more convenient, safe, and efficient way to charge our devices. As the technology continues to develop, it is likely to become more widespread and accessible and to be used in a wide range of applications. So these are the references. Thank you.